Okay, thanks everyone for joining us today. I'm gonna start off with a short presentation just to give you guys some context for what we'll be doing today. So just give me 1 second. Okay, cool. So yeah, today we'll be going through the Ray tutorial. So I'm Stephanie. I'm a PhD student at the Rise Lab. We also have some great TAs with us today who can help you out during the tutorial. So we have Sang, Ramil, Zohan, Suyuan, and Simon on the call as well. So just look out for those people. So before we get to the main tutorial, just some logistics. So first of all, the session will be broken into 3 different notebooks. So unfortunately, the links that we sent you earlier are not currently working. So we'll actually share a spreadsheet with everyone that has a new version of the link that you can click. So if you're seeing something like a page that requests a password, just know that we'll send you the actual links before you get started on the notebook. I'll also start each notebook with a brief introduction talk, and then while you work through the notebook, we'll separate everyone into breakout rooms so that you can chat with the other attendees while you're working through the notebooks. Like I mentioned earlier, please keep your microphones muted while we're in the main Zoom room, just because we have a lot of people in the call. But also feel free to ask questions on the chat. So if you have questions, if you need help, or if you're just wondering about something specific to Ray, feel free to have that on the Zoom chat. If you need more direct help while you're in a breakout room, you can use the raise your hand feature on Zoom, and a TA will try to come to your breakout room as quickly as possible. Okay, so today we're going to walk through an example of using Ray to build a simple online learning system. So we'll use the online learning example to showcase some of the features in Ray. The first notebook will show how we can use Ray to parallelize some work. And then we'll learn about how we can use Ray to serve models in production. And we'll do that using a new open source library called Ray Serve. One of our TAs, Simon, is actually the lead developer for that library. So feel free to ask him questions about Serve through the Zoom chat or on the Slack channel. So one cool thing about using Ray Serve to deploy models is that we can also take advantage of all of the usual features of Ray. So the final notebook will actually focus on adding some custom Python logic to learn each user's preferences online. Okay, so we'll go through first a description of what you'll be doing in Notebook 1. So this first notebook will showcase how you can use Ray to parallelize work over multiple cores in a cluster. So let's take a look at our app and see why we might want to do this. Our example today is going to be based around a movie recommendation app. So here's an example of what the UI might look like. Initially, we'll just have a set of random movies that the user can pick from. The idea is that the user can click on a movie that they like, and based on those movies, we'll try to display some recommendations. And these recommendations will be served through Ray. So instead of building a fancy machine learning model to begin with, we're actually going to start off just by recommending movies based on the similarity of their cover images. So I'm not really sure how effective this is going to be, but it should be easy to get off the ground. So let's get to work. So we'll implement this by taking a movie that the user has liked before as input and performing a k nearest neighbors on it to find movie covers with a similar color palette, and then recommending the most similar movies to users. So we'll use a Facebook research library called FAISS to do this. And to accomplish this, we'll need to do some pre-processing to extract color palettes from the images. So here we have an example for the movie Star Wars. On the left is the cover image, and on the right is the extracted color palette that we can use to efficiently search. To pre-process the images, we're first going to start with a simple script that runs in one process. And then we'll make just a few code changes to use Ray to parallelize it across the cores of a laptop. Or in this case, it'll be across the cores of a Ray machine. So here's a diagram to help you picture what's happening under the hood. Initially, all of the movie cover images will be stored in S3, and the goal is to process their palettes and then store the palettes in a local movie database that has information that we need to access often as part of our web app. The Jupyter session that you're connected to should already be connected to a single node Ray instance. And we'll call this Jupyter session the driver. You can think of it as sort of the root of your application. So the code that you'll write in this notebook will launch many parallel tasks or functions. And each function will get the cover image for a particular movie by downloading it from S3, and then it'll compute the color palette. And finally, the driver will take the outputs of all of the tasks and save them in the local database. Okay, so I think we're ready to get started. Again, please visit the Jupyter link, which we'll send out soon. The link that we sent you earlier to the Raise session will not actually work. So we'll give further instructions on how to do that soon. And next, we'll place you all into breakout rooms of about 4 people each. So be sure to introduce yourself to your fellow attendees while you're in the breakout room. And you can also try to work together on the notebook if you want. Again, you can raise your hand on Zoom if you need help from a TA. And you should also use the react with a yes, the check mark on Zoom, once you finish with the notebook, just so we have an idea of when people are done. And we'll also give a 2-minute warning once it's time to move on to the next step. Okay, hey everyone. So if you didn't get to finish Notebook 1, don't worry. We'll send out a Docker that everyone can download after the tutorial. So you can get the code from there and also from GitHub. So I'll send out the repo for the notebooks later on. So let's try and move on to the next notebook. So I'm going to share my screen again. And yeah, I realized that some of the Zoom features didn't actually work the way that I intended them to. Sorry, we're still also figuring this out. So for this next notebook, if you're having trouble and you want a TA to come to your breakout room, please just let us know by sending a chat to the main Zoom chat. So make sure you're sending to everyone. And once you're done with the next notebook, please also return to the main room by clicking the button that says to leave your breakout room. Okay, so let me get started on the intro for the next tutorial. Okay, cool. So in the first notebook, you guys did some offline processing to collect all of the movie color palettes. Now that we have all of the data, let's try actually serving some recommendations. So here was the goal of our first model, to serve recommendations based on the color palette. But let's say the color palette actually isn't good enough. So maybe we also want to pick movies based on plot. And how can we do that? So my friends in ML research tell me that we can use NLP to recommend movies based on their plot descriptions. So first we'll take a movie that the user liked and search for movies that have a similar plot. We'll implement this using the awesome BERT implementation provided by Hugging Face and another KNN search using the same Facebook research library. Next, we'll use RayServe to deploy our 2 K-nearest neighbors models. At its core, you can think of RayServe as a web server that's backed by Ray, and there are 2 main concepts to understand. There are backends and endpoints. So a backend is an instance or a replica of a model that can be used to process HTTP requests from the web server. And in our case, we're going to start 2 backends, one for color-based recommendations and one for plot. An endpoint is a mapping from the HTTP route to the backend that should serve the request. So for example, we'll have 2 endpoints initially, one for color and one for plot. Whenever a user clicks on a movie that they like, this will generate a user request that hits one of these endpoints, and RayServe will route this request to the appropriate backend. The backend will talk to our local movie database to get information about the movie that the user liked, and using this information, it'll return a set of recommendations that get served to the user. And the same thing happens when the user wants a recommendation based on plot. So let's get started on the second notebook. We'll return you all to the breakout rooms now, and remember to actually let us know on chat if you need help from a TA. We'll also have the TAs rotating through the rooms. And once you're done with the notebook, you can just return straight to the main Zoom room. So again, we'll give you a 1 to 2 minute warning once it's time to move on to the next notebook. All right, cool. Welcome back, everyone. So hopefully you guys enjoyed this first introduction to array surf. We'll go through a slightly more complicated example next. So again, if you weren't able to finish the second tutorial, don't worry, we'll send out the code and a Docker that you can use to run the tutorial later on. Okay, cool. So this next example, in this next example, we're actually going to learn how to deploy an ensemble model. So now that we've deployed our first two models, we need to figure out how to actually use them. So we had two types of models, and ideally we should be able to return both kinds to the user. We can use RayServe to create a third ensemble model, and this will at first look very much like the first two. So we'll deploy an endpoint and a backend. But this time, when a user request comes in, the backend will actually forward the request to the two other backends by talking to them directly through Ray instead of through HTTP. Then this backend will return the combined recommendations. So this is known as an ensemble because we're combining the results of two other models. And the first half of the third notebook will focus on building this part of the system. But we can do even better than this. So let's say that we discover that some users actually have a preference between color and plot-based recommendations. How would we figure that out? Well, so we can actually use online learning. We'll do a very basic version of this where each time the user clicks on a recommendation, we'll use that choice to weight future recommendations. So for example, if the user clicked on this movie, and we remember the fact that this came from a plot-based recommendation, we'll try to weight plot-based recommendations for just this user more in the future. One requirement of this is that we need to be able to remember the source of previous recommendations that we made. Specifically, we need to remember whether the recommendation was based on plot or color. And we also need to remember which recommendations the user liked before so that we can use that to weight the future recommendations. To do this, we'll use a custom Ray actor. A Ray actor is a way to store state in a cluster. So in the first notebook, we looked at how to take a normal Python function and make it into a remote task. But tasks can be expensive for cases where we need to update some state, since that would mean that we have to serialize the state each time we wanted to update it. For these cases, we can use an actor. So you can think of that as taking a normal Python class and instantiating it as a remote object. So for example, we have a counter class here that stores a value that can be incremented. And when we instantiate this class, Ray will create an actor, or a separate process that hosts an instance of the counter class. We can communicate with that actor by invoking remote methods. Each remote method invocation is similar to a remote function in that it happens asynchronously, and it returns an object ref that we can call ray.getOn later on to get the actual result. But this time, the methods can only execute on the specific actor process that we created versus remote functions, which can execute anywhere in a cluster. So here's how we would actually use that to extend the system that we've built so far. When the system starts, we'll instantiate a Ray actor that stores some custom state. And this time when a user request comes in, we'll store and get state specific to that user from this actor. This state will include the source of all of the recommendations returned to the user so far. And the source will just be a string, either a plot or a color recommendation. The actor will also store the distribution for each user so far. So that's just the number of plot versus color recommendations that the user has liked before. The ensemble model will then use this distribution to decide how to combine the recommendations from the plot and color models. Okay, so this is the final notebook. We'll return you all to the breakout rooms in just a second. And since this is the final step, you feel free to just leave the Zoom call whenever you're done with the notebook. We won't have any concluding remarks, but you're welcome to stick around until the end of the session if you have any other questions. And of course, you can reach us over Slack even after the session is done. Thanks for joining us today, and please try to fill out the survey at the end of this notebook if you can. It'll help us a lot with future tutorials and with the development of libraries like RayServe. Thanks again for joining us.